Today we move forward to section 4.1. We're going to talk about things I know, you just might not know the names. We're going to talk about the commutative, associative, and distributive properties. And I know you know these things, you just might not remember what the names mean. Anybody know the commutative property? What's 5 plus 2? 7. What's 2 plus 5? 7. That's the commutative property. What did I do? I switched the order. So the commutative property of addition says A plus B equals B plus A. You can switch order when you add. When else can you switch order? When you multiply. So I'm not going to write it all out. There's also something called commutative property of multiplication. That says A times B equals B times A. So somebody might say, use the commutative property. Three plus x. Is 3 plus x okay? Sure, it's okay. But what if I told you to use the commutative property? How would you rewrite that?
3 plus x equals x plus 3?
You would write equals x plus 3. Usually when we write expressions, usually we put the things with the letters that come first and the things with just the numbers second. So writing something as 3 plus x is okay. Usually we write it as x plus 3, and that would be the commutative property. We simply switch the order. Or I might say use the commutative property x times 2. Now that one looks really funny to me. We usually don't write things as x times 2. We usually write them as 2x. But it's the commutative property that allows us to do it. It's the commutative property that allows us to just switch the order. Does the commutative property work for subtraction? No?
Negative.
Sometimes you get a positive, sometimes you get a negative, don't you? 5 minus 2 is 3, but 2 minus 5 is negative 3. You don't get the same answers. Does the commutative property work for division? No? What's 4 divided by 2? 2. What's 2 divided by 4?
5.
It's a half, isn't it? It's not the number 2. So can you switch order when you divide? Okay, so that's the commutative property. What's the associative property? No. It only has to do with adding and multiplying still. Associative property. Again, there's 2 of them. There's one for add, there's one for multiply. The associative property says this. So what's that mean? What did I do?
You can make it a little bigger. I don't have my glasses on.
What did I do there?
Switch the B and C.
I switched the parentheses, didn't I? At first the parentheses were around the A and the B, and later on I put the parentheses around the B and the C. How does that make a difference? What do the parentheses tell you you have to do?
You have to do those first.
You have to do those first, don't you? So what I'm saying is, if I tell you to take 2 plus 5 plus 6, I'm claiming that's the same as doing 2 plus 5 plus 6. All the same numbers, but the way I write those makes a difference in how you do it, doesn't it? Because on the left-hand side, what would you have to do first? 2 plus 5, because it's inside the parentheses. So on the left-hand side, we would have 7 plus 6. 7 plus 6 is 13. Where on the right-hand side, because the parentheses are around the 5 plus 6, what do you have to do first? The 5 plus 6. So that's 2 plus 11. 2 plus 11 happens to be 13. So you can change parentheses and still get the same answer. That also is for multiplying. I can change order when I multiply. I can change parentheses. A times the quantity BC is the same as the quantity AB times C. Again, you can try it. Unfortunately, this does not work for division, and it does not work for subtraction. Just pick 3 numbers for A, B, and C that you like and put some brackets around them and try it. It doesn't work, unfortunately. Okay, so here's how this gets used. What if I gave you 5 times 3x? What can you do with 5 times 3x? Why 15x? Why do you multiply the 5 times the 3? You're exactly right, by the way.
5
The
times
three's inside.
x would be the same if it was multiplied by the 3.
The associative property says we can change those brackets if we want to. So we can put the 5 and the 3 together and deal with them. 5 times 3 is 15. Now, the reality is, do we normally show all that work? No. If I gave you 2 times 7x, I would expect you to right away say 2 times 7x is the same as 14x. But what you really did there, you really used the associative property. You grouped the 2 and the 7 together and you multiplied those. What if I gave you x plus 2 plus 6?
X plus 8.
That's really the same as x plus 8. And again, I really wouldn't expect you to show all this work, but truthfully what you're doing is you're using the associative property to change the brackets. And then you can do 2 plus 6. 2 plus 6 is 8, so that would be x plus 8. Again, I would hope that you would go from here directly to there, but what allows you to do that is the associative property.
So if you tell us to show all of our work, do you expect us to do that?
No. The directions here would be simplify using the associative property, and I would just expect you to write x plus 8. Now, if I were to do this, if I were to, I can't do that yet. We got to talk about the distributive property. Tiv, spelled it wrong. Property. Does anybody happen to remember the distributive property?
Isn't that where you're like?
Yeah, it's where you do that.
I can't explain it.
So where do you do that? I know what she means.
Wouldn't it be like, where if you had like, say like 2 numbers adding inside the parentheses and then you had a number of times and on the outside you just times it by each number and then add those together?
That's exactly what it says. If you have a number outside a parenthesis and you're adding inside or subtracting inside, it doesn't matter, you can add or subtract. I'm just going to write down the add. You can do this, and she was going like this. And what she meant was you can take the A and bring it into the B, so you have A times B, plus, and then you would have AC. Of the 3 properties, this is the one we usually use the most because we're going to have something like 3 times x plus 2. What does the distributive property allow us to do? Rewrite that as 3x plus 6. The distributive property allows us to get rid of the brackets. We just take the 3 and we distribute it in. So we take 3 times x, that's 3x, plus we take 3 times 2, that's 6. Questions on that? So what I was about to say was, if I gave you something like this, I would expect to see some work show. Let's say I gave you 4 times 2x minus 9. I said minus, I wrote plus, so I guess we'll stick with plus because I wrote it in pen. 4 times 2x plus 9 plus 3x minus 8. Put a whole bunch of stuff there. What would you do? You start with the parentheses. Can you do anything inside those parentheses? No, because one of them has an X and one of them does not. So the next thing you do is you go outside the parentheses. That would be the distribute. So I distribute. What's 4 times 2x? 8x. What's 4 times 9? 36. Plus 36 plus 3x minus 8. Then what do you do? Combine like terms. Excellent. And what do you mean by like terms?
Like x
X
and the
plus
regular.
3x.
So the 8x and the 3x are like terms. What makes them like?
Do they have x?
They both have x's. And what else are like?
The regular number.
The 36 and the 8. They're like. How come?
Don't.
Because they're just numbers. So when we say like terms, it's not like Facebook, right? You don't get to decide what is like and what isn't like. When we say like in math, we mean a very specific thing. All right, again, I'm going to write in a step that I would not normally expect to see, but here's what's really going on. So I'm going to write it in green. And you tell me what I did. What did I do?
Just organize them. Like, you're gonna obviously do the 8x plus the 3 first, and then you're gonna take 36 minus the 8 second.
Okay, so what I did is I put the like terms next to each other. What property allowed me to do that? Which property did I use right there?
The associated.
Not the associative. The associative property has parentheses. Not the distributive. It's got to be the only one left. It's commutative. What did I do? I took the 36 and the 3x, and what did I do with those two? I just switched their order, didn't I? I switched their order. So that right there, that step is the commutative property. Again, I wouldn't really expect to see you write that down, but that's really what's happening there. We use the commutative property to put the like terms next to each other. Now what I would really expect you to do is say, well, I see an 8x and a 3x. 8x and 3x makes 11x. And I see a 36 and I see a minus 8 plus 28. So that's the work I would expect to be shown. I wouldn't necessarily expect to see that green line in there. Questions on that? What if I asked you to take -3 and multiply it by 4x minus 2y plus 5? What if I have 3 things inside my parentheses and I got something out here?
You still do the same.
It's still distributive property. The distributive property goes to all 3 things. But there is something you need to be very careful of here.
The negative.
Order of operations.
The order of operations is one thing. We always got to be careful of that. What I was thinking of was that minus sign. You need to remember when you're distributing a -3. So what's -3 times 4x? -12x. And here's where people start to forget. What's -3 times 2y?
6y.
Plus 6y. A lot of people will forget the minus and they'll write minus 6y right there. Plus 6y minus 15. Very good. So be very careful of your minus signs on problems like that. It's very easy to forget and distribute that minus sign through. All right, here's my last one of the day. What if I gave you, I don't know, give me some numbers. I'm running out of numbers here. 6 minus 3 times 4x minus 9. What do you do?
I have to do outside of the parentheses first, right?
You gotta do the 3 first.
-3 times 4.
Yeah.
Okay, so the common mistake people will make here, many people will make a mistake, they'll go 6 minus 3. Why is that wrong? You have to do multiplication first. That 3 is connected right there
Please excuse me, dear.
by a multiply. So you have to do things in the order of operations. And in the order of operations, multiply comes before subtract. So that's a very common mistake that I'll see people do. They'll go 6 minus 3 first. What you're going to do is you're going to go 6 And then you're going to distribute, and you're going to have
-12.
negative 12x
Plus 27.
plus 27. Excellent. Why is it plus 27?
9 times 3, and they're both negative, so they...
You're distributing a negative 3. That sign has to go along. Negative 3 times negative 9 is positive 27. And again, I'll see a lot of people put a negative 27 there. Do you have any like terms?
Yeah, 6 and 27.
6 and 27 makes 33. And what about the 12x? Negative 12x plus 33. And again, really what we did right there is, truthfully, we used the commutative property to switch the order on those two to put the 6 next to the 27. But again, I don't expect you to show that work. Questions on this?